Hit the lights!
You've discovered the Halfwatt podcast. We want to educate and entertain by tapping into the most trusted source of new technology, the ones installing and innovating it. You, the tradespeople that build from the ground up. Join us as we talk with industry leaders, veteran contractors, and even some young blood.
Welcome aboard. Say, before I start the show today, I want to remember a person that we've interviewed on this show, and that would be Michael Baker. Michael Baker, I met because I helped hire him when I was manager at Performance Systems. And during the interview process, he and I got to talking, and Navy guys always talk about Navy stuff because that's what Navy guys do. And I realized that he had been on a ship that I knew was fairly famous. And I said, well, you know, you were a nuke MM, which is means that he worked in the nuclear propulsion section of a submarine, and he basically worked on the components that help support the reactor, which is a pretty, amazing feat in itself. And he goes, well, I was on the USS Halibut. And I went, wow, the Halibut. I said, that's the ship that helped find the Soviet submarine that had sunk northwest of Hawaii. And he looked at me and his eyes got real big and he said, wow, how'd you know that? Well, I said I had just, a few years ago, I read a book on that and I thought it was pretty amazing stuff. And he goes, yeah, I was on the sub as they were out searching for that. And if you don't know the story is about a Gulf II Soviet submarine. It was hull number K-129, and it actually surfaced and attempted to fire a ballistic missile, and a device that the U.S. government had made sure that the Soviet Union had access to. That's called a PAL. It appears as though that PAL device went off, and the submarine was destroyed and sunk. The USS Halibut was reconfigured because its initial design was to fire off Regulus missiles, which were big, huge things. So it had a funny looking top to it. If you look up USS Halibut online, Wikipedia will show you what it looks like, and you can get an idea how big these missiles were. So a captain named Craven, this was a very famous captain who had a lot of degrees, and he was able to locate items on the bottom of the seafloor because he'd done a lot of math and knew how to find things like that, and that was a specialty. He opted or pushed for one of two ships to be modified. Halibut was one of them, and they actually added some devices so that they could scan for debris on the bottom of the ocean. Eventually, the very famous millionaire Howard Hughes bankrolled a device or a ship called the Glomar Explorer, which went out and retrieved portions of this submarine. So Mr. Baker was on board the submarine during those excursions, and I don't know if he was on it in its follow-on life, but it was also responsible for helping to tap into a Soviet underwater line, a teletype and voice communications line that ran between Petropavlovsk and Vladivostok in the Sea of Okhotsk. So this ship was modified so that it could spend enormous amounts of time on the seabed, and then people could go out and do the tapping. That was called the Ivy Bells. So Michael was shocked that I knew some of those things, and we sort of struck up a relationship, and I always had was very fond of Mike. And if you've ever seen him before, because he taught for IEC and he taught for JATC, he was an instructor for MIRCOM before that. He had written curriculum, so he had taught and even had helped usher in apprentices years and years and years ago. So he has been in the fire alarm industry for, I'm going to take a wild guess, 30 or 40 years probably. He was a very big part of this. Anyway, Mike had been suffering from cancer, he passed away the other night. Would be the 6th of December. And I just found out about it today, which is kind of sad. I didn't get a chance to see him on hospice. Shame on me. I just didn't stay in communication with Cynthia as I probably should have. I wanted to share, though, that Mike touched a lot of people in his time on this planet. And just be aware that, we all have one life to live, and it comes to an end, and that's that. But I want to say fair winds and following seas from Mike. And keep him in your thoughts. Keep Cynthia in your thoughts, and his family. He had a lot of family. When he wasn't working in the fire alarm industry, he would usually be with his son, who had one of those mobile tool trucks that would go and visit auto shops and stuff. I believe it was a Snap-on truck, but don't quote me on that. And he would help with those things. He was very involved with his kids. So I do wish his family the best, and I hope that you bear that in mind. So we wish them all the best. Okay, I am going to change gears and talk about something a little bit different today. Don't want to bum people out. I get how things happen. I have witnessed a lot of that happening, and you breathe deep and you focus on what's going on, and that's what we're going to do. So I'm going to dedicate this podcast today to Mike, and we're going to talk about some technology. And so for those of you who know me, that have suffered through my classes or know me personally, know that I like to think. I really do enjoy sitting and thinking, and I don't get enough time to do it, but by golly, I give it my best shot. And when I get involved in a project or get involved in something that attracts my attention, I will usually not obsess over it, but I'll follow it to the nth degree. And I really enjoyed World War II because it brought the change in technology around World War II. I found to be very jaw-dropping and unexplainable in some cases. And so, like I said, if you've suffered through my classes or if you know me, I'll try to bring that up in conversation, or I'll say, this happened then, and this is how these things work. And I make it a point when I talk to my students of simplifying things that they may have thought or were told that this is really complicated and you'll never really figure it out, or maybe you should go to college or what have you. And I, of course, push back and go, no, this is all understandable stuff. So in the DC to Daylight lecture, which is the very first podcast we have up here, I briefly go through mostly the different modes of radio frequency stuff. And I'm just going to give a very generalization to it. I'm not going to get into the specifics. We can talk physics until your ears pop off, and that's not what this is about. But recently, there's been a big, a big interest of mine to sort of follow the UAP, UFO thing. And this started because of a friend of mine that worked with me at Western States and then also worked with me at PSI. Happens to be the brother of the guy who runs the studio here, so we all kind of know each other. He asked me to listen to a podcast by Rogan and listen to this pilot talk about the Tic Tac video. So I said, sure, I'll listen, because if someone's BSing, I'll probably be BSing about the military and BSing about Navy stuff. I might be able to at least listen to it and tell you if I think the guy's full of crap or not. And of course, I listened to this podcast and my jaw hit the floor, because the commander who was interviewed was absolutely a absolute F-18 driver. I mean, this guy was a pilot's pilot, and it was very apparent to me in about 5 minutes that he was not a BS artist. So I listened to this podcast, and I listened to it again, and I went, holy crap, you've got a guy flying an F-18 who says, "Listen, this is what I saw," and I went nose to nose with this machine, and it just said, "See ya," and disappeared and popped up 60 miles away, out of his radar range and out of his visual range in, I don't know, less than a second or something. And as that podcast unfolded, it really brought to light that the Navy is not an institution that just allows crackpots to fly F-18s or F-14s or anything. And so I knew that Fravor was absolutely telling the truth, that his wingman or wing person actually was also telling the truth, and you can listen to her version of what happened. The op area they were in off of San Diego, I have been in. I can't even tell you how many times, a dozen, 20 times. I couldn't even tell you. I was on 4 ships, and we went in and out of that op area on at least 3 of them all the time. So I've been in the same area they're talking about. I know exactly where they're operating. Now, I obviously didn't see any, wacky stuff, but boy, I sure wish I had. And then pilots on the East Coast were then coming forward and saying, well, okay, we have seen these devices, these things flying around for years, and matter of fact, they become hazardous navigation. We almost hit one. So Lieutenant Graves, who talks about that on the East Coast, you've got Fravor talking about stuff on the West Coast. Now my interest is up. Now I need to kind of get my juices flowing and see just what all this is about. And I look at stuff from 1,000-foot view, and then I try to find an aspect of what was going on, what was being talked about, what was being said, and not listen to the fine details yet, just the overall picture, the overall scene. So one of the things I picked up on was that the earlier versions of the F-18 were not seeing these devices, these flying machines. The later versions, the 3rd generation radar that is on the F-18 is now seeing them, or was able to see them. I remember when I was in the military and looking at the F-18's radars, the original ones, the first generations when the F-18s first came out, I remember what that radar looked like and its capabilities because I was on the receive end of it all the time. So I could look at a radar on my equipment and kind of get an idea of just how much information it was receiving or packing into each sweep of its antenna if it manually did that. And the more you work in that field, the more you realize some radars are just basic, hey, this is out at this distance and at this bearing, and that's it. That's all I'm really after. Some radars move just a crap load of data in them. They just have a lot of information happening. They have a lot of different modes. You know that they're moving information to the weapon systems, and there's just a lot of things happening. And more these radars are so advanced now that if I was to get back in the fleet and try to get my head wrapped around it, I would have a learning curve. So I thought, wow, the technology is really changing. I mean, we're producing some pretty wild stuff, and most of you listening to this podcast don't know shit from Shinola about radars, and I get that. And they're not an easy thing to understand, but they're not impossible. So I'm minding my own business as I do, and I work with a gentleman who I've interviewed on this podcast before. His name's Alan Rader, and he and I are talking about this, and we casually bring up the subject, and he says, and he's got loads of data on this. And it was just like I opened up a keg of beer, and just all this information just spews out. Now, Alan is probably one of the brightest people I've ever met in my life. So it really doesn't matter if it's a subject he knows about. He doesn't inundate you with useless stuff. He just has the information that you need, and will tell you, hey, well, you should look up this or you should look up that, at the top of his head. He just can go, oh, well, you should look up the RB-47 incident of 1955. wow, where'd that come from? And that's just the way Alan is. He's kind of like a walking encyclopedia. He doesn't think he is. We all know he is. And anyway, so I said, so you've got a lot of experience in this. Oh man, I've chased UFO stuff for years, and I don't know what the hell to think of it. But you should probably check out these books and look at this stuff. So I look at an incident that he asked me to take a look at, and it was a RB-47, which is a bomber that was converted into an electronic warfare aircraft and flying in the southern states in 1955. And I read the report, which was accepted in by Project Blue Book at the time, and I realized that once again, from a 1,000-foot view, that there were some things that folks probably didn't pick up on in the report that were blatant. And I talked to Alan about that, and he went, that's pretty intuitive. You should probably consider reading like this book or this book. And that led me down this primrose path, which I've been on for, I don't know, months now, I guess. I guess since I listened to the Rogan podcast years ago, but I've really been on a kick on it lately. And one thing led to another, and I can't tell you what is going on out there. I don't know, and neither do you. No one knows. We can take a wild guess. We can hope that the government's going to tell us, or that little green men are going to show up and kick us in the butt, or what. I don't know what the hell's going to happen. But one of the books that I kind of was prompted to read was written by a guy named Colonel Philip Corso. Now, he retired, and he's passed away as well. But the book is called The Day After Roswell. And so I have only read, probably maybe I'd say half a dozen books on UFOs, UAPs, alien stuff. It just has not been my forte to just jump into this because of I just didn't see a reason for me to really look at it. Now I'm kind of picking that up and running with it. Now I'm 10 times as likely to have read a book on World War II or Vietnam as any UFO book that you could pull out there. If you pull out a book on Vietnam, I have probably read it, or on World War II. So I read this book, and it hit a part where in this book, the Roswell crash happened. This particular individual wound up years later in 1962 working at the Pentagon and being in possession of some of the things that were recovered off of the crash that happened in Roswell. And what these folks did, what him and his boss, a general he worked for, did, is they introduced some of the technology into the industry, the defense industry, so that they would reverse engineer what was there and use that technology to further the military complex, the military industrial complex. So I'm reading this book, and I'm finding it quite fascinating because if it's as accurate as the book appears it is, it's a jaw dropper, and I would highly recommend it. And I get to this chapter on the integrated circuit chip, and I'm telling you that I read this chapter twice. Now I do audiobooks, so I listened to the chapter, and I stopped it, and I rolled it back, and I played it again, and I think when I got to work, because I usually listen to my books when I'm bike riding, I got on Amazon and I ordered a copy of the book, which I have in front of me today. And the reason I did that was I don't know if this colonel wrote this book himself or he had a ghostwriter. It looks like he probably had an assistant, somebody, probably William Burns, Birnes, who helped him write this. But whoever authored this particular chapter on what's called the integrated circuit chip is a stroke of genius. And I wanted to kind of cover that tonight and explain why. One of the things I point out to my students is that when you go from Kitty Hawk in 1905, and let's all remember our history, that's when the Wright brothers made a cloth and wooden aircraft with a bicycle engine on it and flew it in Kitty Hawk and, a couple hundred feet. And that was that. And that was, we could really say that was our first kind of motorized type flight. And it sort of began, a pretty quick technology revolution that moved towards, biplanes and then back to monowing planes and eventually into, planes that weren't necessarily covered with fabric. Now, in 1905, the Wright brothers flew their aircraft. By 1945, 40 years, we were flying over Japan with pressurized bombers, B-29s, the most expensive weapon ever created at the time. It was more expensive to create the B-29 bomber, the Boeing B-29 bomber, than it was to create the atomic bomb, which it was carrying. So the two most expensive weapons programs ever flew over Hiroshima and Nagasaki and dropped two different styles of atomic weapons and put an end to World War II, essentially. 40 years. 40 years. Now, this would be a head scratcher for any civilization to really consider. I'm 59. I remember being 19. I remember where I was at 19. If I look back at 40 years from when I was 19 to what I am now, there's been a lot of technology change. Trust me, I get it. This, however, seemed to be a very steep curve as to what we have today. Now, I reach over as I say that as I grab my iPhone, which has more computing power, more connectivity, more abilities than all of the computers, probably up to the early 80s. So I'm not saying that technology isn't jaw-dropping today. It is. But what I'm saying is when I teach my students about technology and I teach them in particular about computers, this particular chapter in this book is so well done and hits the mark so well that it needs to be talked about. So I don't want to plagiarize this work. I don't want to just take it and steal it. But the basics on this particular chapter that I want you to take away today or tonight is that when I discuss computers in my classes, I usually talk about tubes because prior to tube computers, which would be a tube either operating or not operating, we would call that saturation or cutoff. Prior to tubes, the computers that the military used were mechanical. And I recommend students in my specialized controls class watch one of 4 videos, and I recommend all 4, on gun computers that the Navy used on their ships. So if you're not familiar with this, let me just briefly take a little dive here. In order for you to accurately put a round from a ship, from a cannon, into another ship or into an aircraft, you have to figure out where that shell is going to land. And if you think you can just look through the sights and aim it, you're fooling yourself, because the horizon on most ships is 13 miles away, unless you're a flat earther. But it's about 13 to 14 miles away. If you're on a very tall ship like a battleship, it might be a little bit further out. That's it. Some of these cannons could fire 21 miles, which means it's, follow me now, over the horizon. So if you fire a cannon from a moving ship, you have to compensate for wind, the charge, how heavy the round is, the movement of the target, the movement of your own ship, the pitch and roll, all these things. It's crazy. So they made mechanical computers to help compensate for that. And they did the same thing for shooting down aircraft. If you were trying to shoot down a Japanese Mitsubishi Zero that's moving at 360 or 400 miles an hour, and you're throwing rounds up at it, you have to be ahead of it. You have to figure out where it's going to be in order for your round to hit it or to get close enough to it that if they had proximity fuses, that you might be able to knock it out of the sky. Or if it's flying at you and you can't shoot it down, it's going to smash into your deck, as the kamikazes proved towards the end of World War II. So the mechanical computers and people who watch these videos can get an idea of just how difficult the calculations had to be. So these mechanical computers could do mathematics just with gearing, with the different types of gearing. So if you go to YouTube and you search for naval gunfire computers, you will find the black and white 4-part series where it explains to mostly sailors, because that's what it was videoed, or that's what it was filmed for, to get their heads wrapped around the mechanics that will calculate all the things you need to get around accurately, hopefully, before the enemy accurately puts one on you. Now, I also talk about the computer that helped break the German cipher called the Enigma. And if you're not familiar with that story, the Polish had built this machine, and it was more of a concept. It was a machine, but they really didn't get a chance to complete the work. As Hitler invaded Poland, they took the machine. Before Hitler invaded Poland, they had taken the machine out of Poland and moved it to the United Kingdom. And so it became the main focus of a gentleman named Turing, who then modified it with a bunch of other people, but he was the kind of the mastermind who could see the beauty of this Polish design machine, and he modified it to make it better and better and better. And it was electromechanical. So it had both electronic and mechanical components. So the whole machine, once it finally was up and running, and they had spent a lot of time engineering things to make it do, what it would do was the Germans would send out messages that always had the same phrases. So they would look for those phrases, and they're called cribs. So they would set the machine up to then run through all the messages that were being recorded. And I'm being recorded by generally women, but not always, but operators listening to the radio systems or radio circuits and writing down the Morse code as they heard it, put it in a basket. People come by and grab that, run that information through this machine. If they could figure out what the crib was, they could decrypt the messages for that 24-hour period in World War II. Now, a side note, what do you do with something that you've encrypted and not let the enemy know that you've encrypted it? If you appear everywhere the enemy thinks that they have gotten one over on you, well, then it's not going to take them too long to figure out that their systems have been compromised. So that leads to a whole different discussion I'm not going to go into today. So those are the two general computers and thinking machines that I bring to my students' attention and ask them or push them into sort of opening up their eyes so they get an idea of where our modern computer systems come from, because they all come from this. They all start from this. So I mind my own business as I do. I'm reading this book on the Roswell crash in 1947, and this particular chapter goes into the history of computing all the way back to the early 1800s, which I had no idea because I hadn't really looked at the thinking machines or mechanical thinking machines back to that degree. It just hadn't really dawned on me. I just assumed that it's somewhere along the line, probably in the 1900s or maybe late 1800s, somebody had come up with a thinking machine, and then they just sort of, went from mechanical to electronic. And I didn't really think about the evolution of that until I read this book. So they go back and they talk about how in the initial design of some of these machines, some of these mechanical thinking machines that were really put together back in the early 1800s. They had been around for years and years and years. They had looked for a way to make them more efficient and faster because mechanical thinking machines, were limited in their speed and their ability to calculate. And so some of the mechanical thinking machines were pretty impressive. Some of them used decimal. They actually you could enter information in base 10. However, all computers today use binary. And so when you think about the evolution of a machine and people are thinking in base 10 and the machine has some limitations because it's very difficult to get 10 states of a certain relay or a switch, you do easily get 2 states. Just the evolution of using a 2-state solution, an on or an off, a 1 or a 0, is revolutionary in itself. And the book talked about when that happened, when they made that change from base 10 to base 2 in the logic that the thinking machines were using. So very famous names and very famous company names came out of this. IBM was one of them. And so, for example, in the IBM punch cards, which I had no idea how long punch cards. And now, if you don't know what a punch card is a card is a card that was about, I'd say, 3.5 inches by maybe 6. They were like a hard card stock. They had a bunch of numbers on them, and you would punch out holes. They had a machine that would punch out these little rectangular holes. And you would put a stack of these cards into an IBM machine, and they would just eat the cards. They would just suck the cards in. You couldn't even see them. They moved that fast. Because of how the punches were made on the card, little fingers, pawls, would feel where those holes were and select different ways for the cards to get sorted. So you'd put a stack of these cards in and you'd hit the button, and then they would be kind of, the machine would eat them, and then they would put them in different baskets in different orders. First time I saw this machine, I kid you not, first time I saw this machine was 1984 when I was on the USS Denver. The Denver was, we'd finished our Westpac and we were put in the yards, which means that they got to do an overhaul on you. And they took all the spare parts off the ship, and that's a lot, okay? Kids, that's a lot of parts. They put it in a warehouse on the base, and then they selected, 15 or 20 of us dropouts off the boat and sent us in there to help the SKs are called, the storekeepers, inventory all of the items. And so what they were doing is, as they would add new equipment to the ships, they would take out the inventory that they didn't need and add the inventory that they would need, and then check that all the inventory that was supposed to be on the ship had been counted 3 times and it was accurate. And they were using these IBM punch cards. So you could see that each punch card was for a different part, and you would be handed a bunch of punch cards, and you would go to a location written on the card and count what was there. And it could be anything from ball bearings to propellers. Who the hell knows? I mean, it could be tubes, it could be, synchro servos, or I mean, honestly, it could be anything. Every item on the ship was taken off and put in this warehouse. And we're not talking a small warehouse. So a bunch of us misfits were running around with these cards in this warehouse, verifying the inventory. And then you'd write it down with a pencil, you'd take it back to the guy who would then run it through the machine. Eventually, it didn't take some of us long to figure out that we could actually read the punch card ourselves and figure out what the number was supposed to be. And then you could cheat the system. So I remember the day I figured out how to read the punch, no one else would tell you. No one would tell you how to read the punch cards. And I was blown away that they were still using this particular system in the 80s. So, and the machine was like not a small machine, by the way. So one day I guess I looked at it and went, oh crap, that's how you figure it out. I figured out how to read the thing. And I was like, well, this will make my job much easier if I just put down 7, if that's what they're expecting. So I came back with a stack of cards where I'd written all these numbers on there, and the SK looks at them and they're all 100% accurate. And he said, "You're out." That was it. That was my last day there, and I sent right back to the ship to go chip paint, because this was a better duty than chip and paint, which I just screwed up. So back to the ship I went to chip paint with my other fellow misfits, and off we went. So that system and those punch cards was still being utilized in the 80s, yet the technology literally was from the turn of the century. Okay, the early 1900s or before. So my whole look at how World War II was this big technology change, which it was, has kind of been revamped, because this particular book has opened up my eyes to the dates of when real thinking machines were put together, and the evolution of thinking machines from base 10 to base 2, and from mechanical components to electromechanical components to then all electrical components, being all tubes, and then eventually to solid state. So if I can represent number crunching in ones and zeros versus base 10, then I can move to an electronic version of that, the tube systems. If I could then miniaturize the tubes and make them not as brittle and sensitive tubes. If you're not familiar with how tubes work, they're very hot. They get very hot. They don't last forever and ever. They're vacuum tubes, so they will burn out eventually. They consume enormous amounts of heat, and they don't change state very fast. So there was a big push to get solid state switching devices. And I've always taught my students that Bell Labs was in the process of looking at these, at creating what we would consider a transistor today. And there was a gentleman there named Shockley and his assistants who were working on the transistor, which Bell Labs was the one. So William Shockley was the guy. So William Shockley was actually working on the version of the transistor in 1946. However, when this machine bounced against the desert floor in Roswell, New Mexico, they took some of the technology and they ran it by Bell Labs. And so Bell Labs was one of the groups that got to sort of look at the technology that they had recovered from this craft. Now, that's not how the transistor was necessarily invented, but it certainly helped usher in miniaturization and integrated circuit chips, according to this author. Now, if you think I'm blowing smoke up your skirt, well, then read the damn book. But I will tell you that this guy's chapter on computing and this guy's chapter on solid state computing is worth a look. It's worth a read. And I don't want to plagiarize the book and give it all away. But one of the things he talks about is that the radio vacuum tube reached its greatest utility from the 1930s to the 50s, which was true, because the radio vacuum tube was what amplified sound, amplified radio frequencies, could make on and off decisions if you knew what you were doing with it. It would act as a diode. There were tubes for a bajillion different reasons. And if you grew up, when I grew up, tubes were very common. So at some point when they shifted back over to trying to create these solid state units, when they did actually create them, and once again, this chapter goes into it, he discusses something called the analytical engine. So the simple principle behind, now I'm reading right from the book here, and I'm not going to bore you, but the simple principle behind the first computer, called by its inventor the analytical engine, was that the same machine could process an infinite variety and types of calculations by reconfiguring its parts through switching mechanism. The machine had a component for inputting numbers or instructions to the processor itself, which completed calculations in a central control unit, or CPU, or we would call that central processing unit, that organized and sequenced the task to make sure the machine was doing the right job at the right time. A memory area for storing numbers, and finally a component that would output the results, the same thing that a printer would do today. This was in the 1830s. This was in the 1830s that this analytical engine was pieced together. We didn't see electronic computing happen, all electronic computing happen, until the ENIAC machine came out, or ENIAC machine, I should say, years later. Sometime after, I'm looking in the book, so give me just a second, 1948. 1948, because remember that Shockley was working on his transistor in 46. The Roswell crash happened in 47. In 48, the first junction transistor. I'm not saying that the Roswell crash created the junction transistor. Shockley was well on his way to that. But the junction transistor, a microscopically thin silicon sandwich of N-type silicon, all right, and we talk about that. If you have a diode, it's an N and P-type material. If it's a transistor, it's an NPN or a PNP. And we just say there's N-type silicon and P-type silicon. But a silicon sandwich of N-type silicon in which some of the atoms have an extra electron, and P-type silicon in which some of the atoms have one less electrons, was devised by William Shockley. The invention was credited to Bell Telephone Laboratories. And if by magic, the dead end that stopped the development of the dinosaur ENIAC generation, which was the computers that used tubes. Then they began to miniaturize this circuitry. So you could pack many, many, many transistors into a very small space, which is how integrated circuits came about. Now, everybody who knows me and knows where I come from as far as teaching in a teaching aspect is that I discuss the fact that the miniaturization and the production of IC chips in the initial ideas that went with them, a company called Texas Instruments, which is still around, created these circuits and the and, or, nor, NAND logic gates, and that you can actually pull up a TTL logic guide, and you can see one on the web if you want, that will show you an integrated circuit. If it's a dual inline package, which is just the chips that have the little legs off to the side we've all seen, would show you exactly which leg does which function of the logic. If I have an AND gate and I need two inputs to get one output, then, pin 2 and 3 might be the inputs and pin 4 might be the output. You could actually see how these logic circuits were put together. You can see the technology move so rapidly from the end of World War II to where we're at today, and also during World War II. It is worth probably taking some time to really look at the entire century from 1900 to 1999 and look at all of the technologies and how quickly they developed in every aspect. In every aspect. We went from 1905, the Wright brothers, to the SR-71 on the A-12, which are the two fastest manned jets that I'm aware of that could fly over Mach 3.3 in a very short order of time. We had superconductors at once you cool them down to the lowest temperatures you could get to, you could make superconductors. And if you don't know what a superconductor is, it's a device that can move current with zero resistance. So we already knew if we had certain materials, we could cool those materials down enough to move electricity through them without any resistance at all. But to get a superconductor at room temperature was beyond our reach. Now we can get close, but we can't. We still have some work to do there. So one of the principles of superconductivity is I'm going to butcher this word, but it's called dimagnetism, or the opposite of magnetism. So if I have a magnet, and we all know, if we're electricians, we all know that you really can't have electricity without magnetism. You can't have magnetism without electricity. They're let's just call them, two sides of the same coin. If I have a magnetic field and I pass a wire through it, I'm moving electrons. That's the best way to look at it. If I have electrons and I coil them up, I make a magnetic field. So if I have a magnetic field, it will attract most iron or ferrous objects. Or if I have two magnets, if I put the poles the same, like north or two souths together, you'll actually feel the repulsion that the magnet has, and it's intense. It's not a small amount. Repulsion is less powerful than attraction, but it is still there. So, but we can repulse magnet. We can push against magnets of like signs. I'll just say that to the tune of floating a train. And if you look at maglev trains, you'll see that I think the Chinese or the Japanese at this point are producing maglev trains that routinely run at 350 kilometers per hour. Now they're going up to 600 kilometers per hour, moving towards 1,000 kilometers per hour if they can put them in a semi-vacuum tube and run the train with very little wind resistance, with no friction. None. Now let that sink in for a second. So the properties of magnets and the ability to repel and have a frictionless train, okay, move across some rails and be pushed by, basically be pushed by magnetism. We're already seeing this happen in other places as well. The catapults on aircraft carriers, for example, use steam. When I was in, they're moving to electromagnetics if they haven't already done it. We all know the electric cars are incredibly fast. The amount of torque that you can apply to the tires or the wheels, essentially, on an all electric motor is insane. If you put your foot to the floor in an electric car, it's incredible how much torque you can get immediately, right now. There's just almost no delay. So if you could produce a superconductor in room temperature, you would change almost everything overnight. Is that going to happen in our lifetimes? Probably. Okay. I mean, things are going to change shortly. And if you look up on the web information about magnetic properties and superconductors and dimagnetism and all those good things, there's actually a researcher in Europe who floated a living frog, in a tube. Now, he had to have the superconductors around the outside of the tube supercooled in order to do this. It didn't hurt the frog. They dropped the frog in the tube. The frog floated in the tube. And you can see it's not doctored. It's not BS. It's real. They could float small animals in midair by using superconductors and essentially repelling against the I can't do it justice. I'm not a physicist, but you can get my point. That's pretty amazing stuff, kids. So as the world is changing and technology is being brought on board that we're not aware of, I mean, unless you're on the cutting edge reading about, who's making, solar powered desalinization kits, or because you can do that. You can put salt water in it and get fresh distilled water out with very little power now. What's happening in superconductors, what's happening in the world of physics, which affects us as electricians down the road. I mean, if you could put in a system where you had, or something that had almost no resistance, think about how many devices you could wire on any system if you had no resistance to worry about. Think about that for a second. We're limited currently in 2023 anyway on how many devices we could add to a channel of SLC in a fire alarm system because of how far the communications can reach, because of the resistance of the wire, because of the capacity of the microprocessors, the program. There's limitations, and there's also limitations because we don't move advanced fire alarm systems like they do non-UL listed systems or systems that aren't life safety. So in my world, I see technology 10 years behind what folks in, maybe access control or Berg and security stuff see. And so you folks working on some of this new material, new things, you're working on the cutting edge. I'm kind of behind the scenes reading books and being amazed, but it is coming. These things are coming. These technologies are changing. They're changing everything, the way that we practice. The other night I was just sort of daydreaming, and I thought, gosh, we got a Oculus, the third generation Oculus in our home. And the first generation was impressive. If you've not played with an Oculus, it's impressive. The third generation Oculus is really impressive. It takes in walls and ceilings in your home. So one of the setup features they do is this little machines or little animals that climb through your ceiling and through your walls, and you're standing there watching your walls open up and watching these little animals come in, and you shoot them, so you can kind of get your head wrapped around how this technology works. I was blown away by the integrated VR. And I just sort of thought about it after I played around with this headset. I'm not a huge gamer, so it's not, I don't do that a lot. So I kind of sat around and thought, well, gosh, if I had a drone, not a flying drone, but a drone that moved, like it could climb through the ceiling, I could literally attach a wire to that drone and have it climb through the ceiling, attach the wire correctly or feed it correctly, remotely manipulate the unit, and never have to pull a ceiling tile. Okay? I mean, that's just me just sitting around just spitballing. That could be what our offspring or our grandkids wind up wiring. Or will there even be a need for wire? Will everything go wireless? Or will it just be a fiber optic cable we pull and everything's on fiber optics and not even on copper? So books like this that you may laugh at and go, oh, UFOs aren't real, or yeah, I think they are real, or I don't know. I haven't really made a decision yet, whatever. I sort of encourage folks to kind of dabble into some of this and sort of get your head wrapped around the history of what we have seen. And we take for granted, and I guess that's the point of this podcast today, is that we sort of take for granted where we're at in society with the toys and the tools and the machines and the technology that we have. If you're listening to this podcast and you're less than 25 years old, you grew up with the internet. You grew up with handheld devices. You grew up with the ability to get books and listen to them or do they. I didn't grow up with any of that stuff. Most of us older folks didn't. I mean, I certainly had television. I mean, I wasn't living in a cave, but it was black and white, and it was like awful. It was just, there's a lot of commercials, and it was just, you had to watch what was on, and that was it. Now I have more choices than I can't even tell you all the choices I have. I get stunned trying to figure out what the hell I'm going to watch when I watch TV. There's so much stuff out there to enjoy. I'm not being critical of it. I'm just saying that that there's times when I'm so overwhelmed by the technology we have that I fail to look at where it came from. I fail to look at how we got here, some of the people who helped bring it to fruition, what other countries are doing. Like, for example, I talked about the maglev trains and the high-speed bullet trains and stuff like that. We can't have those in this country. That's a long story. I'm not going to talk about it. But moving products by rail and moving people by rail is a very efficient way to move people. And other countries obviously endorse that. We're not one of them. So where we're going to go in the next, say, 40 years from now should be jaw-dropping to all of us, because the curve on this technology, like I've talked about the 1905 to 1945, the curve on that technology, pretty steep, okay? Well, it didn't just drop off after World War II. It kept getting steeper and kept getting steeper and kept getting steeper. For example, when I talked about Mike Baker being on the submarine, if you are not familiar with the fact that our Navy tapped and the NSA tapped into an underwater line that was run between two Soviet military bases, and for years listened to those conversations. The Soviets didn't encrypt a lot of that stuff because they didn't think anybody would ever be able to go to the bottom of the Sea of Okhotsk and tap into their stuff. But we did. How does somebody work on the bottom of the sea, on the seafloor, for hours at a time? It's called saturation diving. There are technologies where people can operate at such high pressures they can stay down there for days at a time if they need to do the work they needed to do. Or if you're not familiar with that or not aware of it, or it hasn't dawned on you that technology is old technology. This happened years, plural, ago. This didn't happen yesterday. I don't know what the hell's happening today. None of us have the clearance to know that. But if you sort of look at the trend lines and you sort of look at the technology curve, if you really haven't sat back and thought about just how much data we can move and how much information we have at our fingertips, we do pick up our phones and get pissed off because there's another iOS update, or my Android does this or whatever. We generally know how to look at it and critique it. I know I certainly do. I get all kind of pissed off at Windows and things that don't work right. But I really I really am taking the technology for granted. So are you. So is everybody. We just don't think about it anymore. So that's what this podcast is about, is that I read this book. I've read several books on it now, and I've continued to research this. This has forced me to learn physics, and this particular mode of study has forced me to learn physics in a way that I never really ever wanted to. Also reading about how they made the atomic bomb, because I've read those books as well. If you're not familiar with how the atomic bomb was produced and how it works, there's a fantastic couple of books out about that. They're very long reads. So we're talking 600-700 pages, but they're worth reading. They'll tell you all of the chemistry, all of the history, who was thinking what, when, why, where, and how they developed in very short order a working device or weapon, and then how we kept just making that better and better and better and better and better. And of course, we just take it for granted. But it came from somewhere, and it definitely is a something that you can study and become accustomed with, and it can be sort of morbid. I'm not saying that it's the thing for everybody. I'm just saying at some point I would like you to think about all the technology and all the advances in things that we've seen. And look at one aspect of it, whatever trips your trigger. Maybe you're into engines. Maybe you're into jet engines. Maybe you're into looking at where jet engines came from and who developed them. And hey, gee, the Germans had jet engines and they used them in World War II. I wonder what happened there. All this stuff is available, and it's available at your fingertips. You can do research on your phone. So please use this technology that we have to enhance your brain, open up your mind, and look at how far we've come and where we're going to go. What are you going to teach your kids? I mean, you're going to tell your kids about, the crazy choices you had on Nickelodeon when you were a kid, and they're going to look at you and go, what the hell's a Nickelodeon? And by the way, what was a Nickelodeon for our grandparents? Because that term Nickelodeon meant entirely something different. If you didn't know what a real Nickelodeon was, look it up. It was a way of looking at movies before the common man could go to movies. It was honestly a device. You put a nickel in and it spun pictures. And you looked at it stereoscopically and it spun pictures, a machine with light. And you looked at it and it threw these images up. So you could see moving pictures, because at the time the Nickelodeons were commonplace, most people had never seen a movie. Most people hadn't even seen a car. Most people didn't have indoor plumbing or electricity. Now, we wouldn't think about living in a place without that. So that's my podcast today. I hope you guys enjoy it. And, thanks a lot. See you soon.
Thanks for listening to the Half-Watt Podcast. We always want to hear from you, and we encourage you to email us at halfwattpod@gmail.com with questions or even your own stories. Funny, crazy, or praiseworthy, we want to hear it all. You can follow us on Instagram at halfwattpod to stay up to date on our feed. And be sure to subscribe wherever you listen to podcasts. And share us with a friend, the best way to help us grow. The Half-Watt Podcast is a production of Now Hear This Studios.